Hello friends, welcome to engineering tutorial. Today we are going to discuss about the method of nodal analysis. It is another method of circuit analysis. In my previous video we discussed about mesh analysis. So today we are going to discuss about nodal analysis. So let's get started. Now the nodal analysis, it is a method of analyzing an electric circuit which is based on Kirchoff's current law. Now the mesh analysis, it is based on Kirchoff's voltage law, but the nodal analysis is based on Kirchoff's current law. So the first thing which we have to do in nodal analysis is we have to determine the number of nodes in the circuit. It is one of the most important steps which is involved while solving a circuit using nodal analysis. You have to determine the number of nodes. Basically, a node is formed when two and more impedances or circuit elements get joined together at a point. So that's when two and more elements, they get joined together, impedances, current sources, generally impedances are involved. That's when a node is formed. Two and more impedances getting connected forms a node. So first we determine the number of nodes, then we assign the node currents arbitrarily, give random directions to the node currents, and then we apply the KCL at the node to find out the current equation depending upon the currents, whether they are entering or exiting from that node. Then we find out the equation for the node current or the branch current in terms of the node voltages. Generally we know that a current flows through a branch from a higher potential to a lower potential. So the branch current is given by voltage at the higher potential minus voltage at the lower potential by impedance of the branch. So it will be easier for you to understand if we solve a problem. So let's solve a problem. Now here there is a circuit network which consists of a voltage source E1 equals to 50 volt, R1 equals to 20 ohm, R2 equals to 100 ohm, R3 equals to 120 ohm, R4 equals to 30 ohm, and this is E2 equals to 20 volt. So the question is to find the current I2 flowing through R2 using nodal analysis. You can solve it by any method, but here we are using nodal analysis just to give you idea how this works. So here we redraw the circuit later, but here just understand these 2 points are shorted. There is no impedance in between. So these 2 points are the same. They have the same potential. If there would have been an impedance connected in between, their voltages would have been different because of the voltage drop across this resistance. So always make sure that if there is no resistance or impedance between 2 points in a circuit, they are at the same potential, they have the same node voltage. So these 2 points constitute a single node, okay. If there would have been a resistance or any other impedance, then there would have been a voltage drop. So then these 2 voltages would have been different, but as there is no resistance in between, so no voltage drop, and these 2 voltages will be same. So the step 1 is we assign the arbitrary currents I1, I2, I3. I1 is entering the node and all others are exiting. They are moving away from the node. this is one node, okay, as there is no resistance in between. So the first step is to develop the KCL equation. Obviously it is evident here that I is equal to I1 plus I2 plus I3. So that's the KCL equation. See here, we have redrawn the circuit. We have connected these R2 and R3 at a single point so that you can understand it in a simple way. There was no resistance connected in between those 2 points that I discussed here. There is no resistance. So what I did is that I have connected these 2 points. I have just connected it, made it one point so that it will be easier for you to understand. So, and I have named it a single node N. Okay, I have connected R2 and R3 together at one point as there was no impedance between those 2 points. So that is one node. See, 2 and more resistances. Here there are 4 resistances connected. If there are 3 resistances, it is one node. In case there are 2 resistances, you have to determine whether it is at one edge or not. Generally, when there are 3 resistances, 3 or more resistances connected at a point, generally it is a node. Okay, so we have developed the KCL equation. I equals to I1 plus I2 plus I3. Now we have to develop the node equations for the branch currents in terms of the node voltage. Now let us name or assign the voltage at this node N, and let's call it V volts. Okay, we are calling it V volts as it is an unknown entity. We have to determine it. So the next thing is we have to express these currents in terms of the node voltages. We discussed it in the previous page that a branch current is given by V at a higher potential or voltage at a higher potential minus voltage at a lower point by the impedance. So let's see. How can we write I? Now here, this is I. It is flowing from 20 towards node, this voltage. Obviously the current flows from a higher potential to a lower potential. So we are going to write it as 20 minus V. The voltage here is V. 20 minus V by impedance R4 is equal to 30 ohm. Similarly, we can write I2 flowing from V, this node, towards ground. So it is V minus 0 volt, ground is 0 volt, by impedance which is R2. I3 is also same, V minus 0 by R3 which is 120 ohm, and I1 is V minus 50, positive to negative we are going, of the voltage source positive to negative, so minus 50. If it would have been connected in the reverse, it would have been plus, as we are moving from negative to positive. So here in this case the current I1 is V minus 50 as we are moving from positive to negative by impedance 20 ohm, R1 equals to 20 ohm. So I have written it here, the same thing. I have developed the node equations in terms of the unknown node voltage. So here it is, I equals to I1 plus I2 plus I3. So when we solve this equation using whatever method, either you solve it in calculator or you use the LCM method to solve this, we get the voltage V as 31.14 volt. Now when we determine the node voltage here, we can determine the current through the individual resistances. Now we are asked here to find out the current through this resistance R2. So I2 is obviously this node voltage minus ground voltage, that is 0, by impedance 100. So let's find out. It is equal to V minus 0 by R2, which is equal to 31.14 volt minus 0 volt by R2, which is 100, which is 0.0 3114 ampere or 300.4 milliampere. Similarly, we can find the other voltages also if you like. This is the other I, 20 minus V by R4, which is equal to 20 minus 31.4 by 30 is equal to minus 11.4 by 30. Now here I told you in the mesh analysis method that when the value of a current it comes negative, it means that the actual direction of the current is opposite to the assumed direction. Now here we just assigned the directions of the currents arbitrarily. Okay, we just assumed it. So as the value of I it came in negative, it means that the actual direction of I is in this way, like this. It's flowing this way, not this way. It is flowing in this direction. Similarly, we are going to find out I3. I3 is equal to V minus 0 by R3, which is equal to 31.4 minus 0 by 120. Okay, so 31.4 by 120, whatever value it will come. So here the direction is plus, so the actual direction is the same as the assumed direction. Okay, the actual direction is the same as the assumed direction. Here there is no reversal of the direction. Similarly, I1 is equal to V, higher potential to lower potential as the current flows. We are taking the assumed direction now. Whatever value the sign convention will come, we will see that. So it's 30 V minus 50 by 20, which is equal to 31.4. Obviously the direction will come negative. Yes, 31.4 minus 50 by 20. So obviously the answer will come in negative. Okay, it will be minus 18.6 by 20. So obviously the answer is negative, so the actual direction is opposite to the assumed direction. I1 came negative, so the actual direction of I1 is in this, towards right, not towards left. It's in this direction. Here we have assumed that I1 is in this direction, but the actual direction is in this. So whenever the value of any current it comes negative, just reverse the direction of the current which you have taken in the diagram. So that's all about nodal analysis. So you can apply it to more complicated circuits. I have taken a simple one just to make you understand, and you can apply it to any circuit, any complicated circuit. And I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electronics and electrical engineering. Thank you very much. Have a great day.